Oh, okay. At a minute late start, but late start's better than no start. We're good at the algebra. There were a couple things that were consistently missed that I wanted to show you, and the first one was in number one. First, as always, check your factoring. Some folks factor that denominator into x plus one, x minus one. That doesn't fall back out to give you a negative x squared and a positive one. So make sure you factored correctly. Always check your factoring. And when you cancel a factor and its opposite, it leaves you negative one. So some of you didn't have negative one over x plus one, and that was a mistake. Now, I wanted to point out this note that was in 2.6 to remind y'all to look at your notes. There was some struggle with the hole in the graph versus asymptote, and that's specifically what this 2.6 note was about. Anywhere when the first thing you always do is factor and simplify the rational expression, but when you get it factored, anything that makes the denominator zero is either a hole in the graph or a vertical asymptote. It's one of the two. And to figure out which one of the two, if you have a factor that can be canceled, then that's a hole in the graph. If you have a factor that cannot be canceled, there's a vertical asymptote. Hey, Miss Lily, let me give you this. Here you go, here you go, here you go. What I did was make us a page with all the algebra done so that we could just do the graphs real quick. So that's how you tell if something is a vertical asymptote or a hole in the graph. If it cancels out, then whatever makes that factor equal zero, that's a hole in the graph. If it doesn't cancel out, then whatever makes that factor equal zero is a vertical asymptote. When you say this is equivalent to this, you're really saying, except for that at that one point that I canceled out. So you should have these two are equivalent everywhere but one, because I can plug one in here, but I can't plug one in here. The fact that that one came from the factor that I canceled out means that that's your hole in the graph. And to find the y coordinate of that hole in the graph, you just put one into the reduced function. Remember, because you can't put one here, but you can put one here, and you get a hole in the graph at negative 1/2. Some of you had that, some of you did not. That factor I could not cancel out gives me my vertical asymptote. If I set that equal to zero, I get my vertical asymptote at negative 1. So I've already graphed the vertical asymptote at negative 1. The horizontal asymptote at y equals 0, and my y-intercept 0, negative 1. Most of you had that, and I just want to show you how to apply that to a graph. Train your eyeballs to think what's going on to the left of that vertical asymptote, what's going on to the right of the vertical asymptote. And even if you just have to cover up part of it, that's okay. I want to focus my eyes on what's going on to the left of the vertical asymptote. I just covered up the right part. I know that to the left, the graph either has to be above the horizontal or below the horizontal. Hey, Miss Michaela, come grab this. We're just redoing the graphs here. Most people's algebra was good. So how can I figure out whether the graph is above the x-axis or below the x-axis right there? I don't have any points already there, so I need to just pick an x and find its value. Let's see, if that's x equals negative 1, what about if I let x be negative 2 in this simplified version? I have a negative over a negative, and a negative divided by a negative is what? A positive. That tells me that to the left of the vertical asymptote, my graph is above the x-axis. And make sure that your graph doesn't turn back up at the end like a parabola. It's supposed to be getting closer and closer to that x-axis. Now, to the right of the vertical asymptote, again, I'm trying to train my eyes to see that, so I'm going to cover up to the left. I'm going to say the graph either has to be above the horizontal or below the horizontal. Do I have something that tells me that, or do I need another test point? Oh, I forgot to graph my hole in the graph. I do have that y-intercept at 0, -1. I should go ahead and put my hole in the graph at 1, -1/2. But now without using another test point, I can see that to the right of the vertical asymptote, the graph has to be below the x-axis. Okay. All right, going on to the next one. I have to stop myself from explaining where all of this comes from, but most of you got that right. So remember the vertical, all of how you find these things is in the notes if you need them. We're just focusing on graphing right now. I have one vertical asymptote, so I'm going to say to the left of that vertical asymptote. Forget there's a to the right. Just think about to the left. The graph either has to be above the horizontal or below the horizontal. Is there a way of determining that without a test point, or am I just going to have to use a test point? So you can always use a test point. When in doubt, use a test point. But actually on this one, there's a reason that I know it cannot be above the horizontal. With me making this motion, can you see what the reason is?
Oh, because they won't get the x-axis.
There's no x-intercept over here. The only x-intercept is the origin. So the graph cannot be above, it must be below. And if you don't see that, then just pick a test point. Just pick, if that's x equals -2, pick x equals -3 and see what you get. All right, that's to the left of the vertical asymptote. I'm going to cover that up and say, what about to the right of the vertical asymptote? Again, the graph either has to be above the x-axis, or excuse me, above the horizontal asymptote or below the horizontal asymptote. Do I already have something that tells me which, or do I need a test point? I have the y-intercept. It's above the horizontal. So that tells me the whole graph is above the horizontal. And some of you did a better job than others at making your graph look like it was approaching both asymptotes, but that shows your understanding of what an asymptote is. So make sure your graph is approaching both asymptotes. So far, so good? All right. Number 3 had 2 vertical asymptotes. So I need to look to the left and to the right of each one. Basically, I need to look at 4 sections of this graph. To the left of the left asymptote, to the right of the left asymptote, to the left of the right asymptote, and to the right of the right asymptote. That's harder to say than it is to do. But I'm gonna just cover it up to the right of this and say, to the left of this vertical asymptote, the graph has to be above the horizontal or below the horizontal. Do I have anything that tells me, or do I need a test point? Yeah, I don't have anything over there to the left, so I need a test point. That's x equals -2, so let's say my test point's x equals -3. I don't really care what y is, I just want to know if it's positive or negative. So I'm going to plug that -3 into this factored form here and say -3 minus 2 is negative. -3 minus 3 is what? Negative. And -3 plus 2 is negative. And when I multiply or divide 3 negatives, I get a negative. So that tells me what's going on to the left of that asymptote. And again. No one is more main than the other. I know what you mean, the middle. You have the middle, but yeah, you just, if you don't have anything that answers that question, is it above the horizontal or below the horizontal? Then you just use a test point. All right, so now I'm covering up, I want to focus on this to the right of this vertical asymptote. Do I have anything that tells me, look up just a second so you can see what my pencil's doing. Could my graph possibly look like this in the middle? The answer is no, but I need you to tell me why. No. What's not negative? The y value? How do you know that? Look what my pencil's doing and tell me, my pen's doing, and tell me why the graph can't possibly do that. And it's this part that's wrong. Why can the graph not possibly do that? Does that make sense? It can't be here because there's no x-intercept right here. It has to be at least that far. Has to look like that, not cross the x-axis again. And obviously it has to hit this point. So I'm going to make it come on down. It's supposed to be nice and smooth, but if I interrupt my graphing, it never ends up looking nice and smooth. It has to get to at least that point on the x-axis. Look up and tell me, look up at my pencil again. Could the graph possibly be turning back up here? Or does it have to be going down here? Is there one of those two options that can be excluded? Not really. I mean, I touched the x-axis there, but touching the x-axis could mean it does a U there, or it could mean it goes on down there. Nothing I have so far tells me that. So what am I going to have to do? Test point. That's 2, 0. That vertical asymptote's 3. So I might have to pick 2.5 as my test point. But 2.5 as my test point, just tell me negative or positive. The numerator will be 2.5 minus 2. Positive 2.5 minus 3. Negative 2.5 plus 2. 2.5 plus 2. Yes. Yeah. So we said negative, positive. That's 2 negatives. What do you get if you multiply or divide 2 negatives? I think I did that wrong. Let me double check. I think I'm saying it wrong. 2.5. Oh, this would be positive. This would be positive. This is the only one that would be negative. So the sign of this would be negative, which is why I know that graph goes down. And then in the same way, to the right of the rightmost vertical asymptote, I don't have anything that tells me if that graph is above the horizontal or below the horizontal. I'm just going to say super fast because we're in a hurry. I've already picked a test point like 4 and got positive, positive, positive. So I know that graph is above the x-axis. Okay. Miss Lily, how's it feeling? Is it making a little more sense? Miss Michaela, how about you? Okay, all right, bless her heart. What time did you have to get up? Okay, let's see if we can do these last ones real quick. Hey, Ben, take 2 of these and call me in the morning. I'm sorry, that's a bad joke. You've ever heard take 2 aspirin and call me in the morning? No, I'm just old. Okay, number 4 has 2 vertical asymptotes and a horizontal asymptote, and that means I need to look at 4 particular sections. To the left of the leftmost, to the right of the leftmost, to the left of the rightmost, and to the right of the rightmost. Every piece has a part of the graph. I need to make sure that I have a graph in all of those sections. To the left of this x equals -4. Look up so you can see my pencil. The graph either has to be above the horizontal or below the horizontal. Do I have anything that tells me which? It cannot be below, or I'd have another x-intercept over here, and I don't. So the graph has to be above the horizontal asymptote. And Michaela and Ben, since you just came in, make sure your graph looks like it's approaching both of those asymptotes. Doesn't curve back up on itself, do some wild backward steep thing. It's approaching both asymptotes. All right, in the middle. Hey, both take 2 of these. In the middle, do I have something that tells me what the middle looks like already? Yeah, I have 2 x-intercepts and a y-intercept. And the only way the graph can hit all 3 of those is to be sort of parabolic looking in the middle. It's not a parabola, but it kind of looks like a parabola. Okay. Is there any way I can tell to the right of this asymptote whether the graph is above the horizontal or below the horizontal? You said that like a math teacher. That's exactly right. Okay. And folks who just came in, I texted everybody last night. I don't know if everybody saw it, but y'all did horrible on the graphing, although you had done good pretty much on the rest of it. So I made us these 2 pages, Bo, that had all the algebra done so that we could just real quickly focus on the graph. All right, and we're up to number 5. Number 5, most of you had, there's no vertical asymptote or hole in the graph, but there's a horizontal asymptote at y equals 4. And the only intercept is the origin. So I don't have a what's going on to the left of the vertical, what's going on to the right of the vertical. It's no vertical. So let me just say what's going on to the left of the origin and what's going on to the right of the origin. For example, if I plug in a -1 without actually plugging it in, can you tell me what the sign of this would be? It'd be positive. -1 squared is going to be a positive, so this whole thing's going to be positive, which tells me the graph has to be above the x-axis and approaching that horizontal asymptote. Miss Emily's, you suddenly had a question mark on your head. Do you need to ask anything? Yes, yes. You are 1 step ahead of me, but you're exactly right. I'm saying certainly if all the x's, if for all the negative x values, this is going to be positive. So here you go, Douglas. So certainly to the left of the origin, the graph has to be above the x-axis and approaching the horizontal. And then like Emily said, for positive x's, the same thing would be true. I would have, what did I do? I meant to, I'll tell you one in just a second. All right, so the graph's going to look the same to the right of the origin because whether you're squaring a positive or a negative, you get a positive. Okay? Any questions? All right, last 2, I told everybody that there were 2 common algebra mistakes folks made, and one was in number 1, determining where there's a hole in the graph and where there's a vertical asymptote, and that's where I put the little reminder. I cut and pasted that straight from the 2.6 notes. When y'all are in doubt of something, go back and look at your notes. I probably typed the answer to your question in the notes. The other thing that several people missed was slant asymptotes. How do I know 6 and 7 both have slant asymptotes? What was it that told me there was going to be a slant asymptote? Again, you can look back at your notes if it's not on the tip of your tongue, right? The degree of the numerator is 1 more than the degree of the denominator, that's when I know there's gonna be a slant asymptote. And I always find that slant asymptote by dividing. On number 7, I couldn't use synthetic division because I was dividing by x squared something something. And we hadn't talked about long division. I knew we wouldn't have time to talk about long division, so I did the division for you. But I expected you to look at it and say, that quotient is x, so my slant asymptote is y equals x. Now, on number 6, you could do synthetic division. So that's what I meant for you to do under the show work portion. Divide x plus 1 into x squared minus x minus 6 by synthetic division, and you get from this bottom row, that's the coefficients of the quotient right there. This last one's the remainder. So the slant asymptote is y equals 1x minus 2. Anybody miss that on the homework, but and still not understanding something? All right. So if you have a slant asymptote, you have to graph that slant asymptote. Y equals x minus 2 has a y-intercept of -2, and then up 1/1, boom, there's my slant asymptote. But I still need to think what's going on to the left of the vertical asymptote and what's going on to the right of the vertical asymptote. To the left of the vertical asymptote, the graph either has to be above the slant or it has to be below the slant. Do I have anything that tells me which one? I have an x-intercept above, so the graph has to be above. And your graph needs to look like it's approaching both of those asymptotes. That's what it's doing to the left of the vertical. Now cover up to the left of the vertical and look at to the right of the vertical. Again, the graph either has to be above the slant or below the slant. Do I have anything that tells me which? I have 2 points below, so the graph has to be below, but it has to be approaching. Ooh, that's hard to do. It needs to look like it's approaching. Some days are better than others. That looks like it's approaching both asymptotes. All right, and the last one, again, has 2 vertical asymptotes, so I need to look to the left and to the right of each one. A big thing here is making all of your asymptotes long enough that you can tell where they cross. I graphed the line y equals x and my 2 vertical asymptotes. So first, I'm going to cover up everything to the right of this vertical. I've already plotted my point 019. Well, no, I haven't. It's right here-ish. And 10 is right here-ish. So I'm going to cover up everything to the right of that first vertical asymptote and say the graph either has to be above the slant or below the slant. Can I figure that out without a test point? Because why? If it was above, there'd be another x-intercept over here, and we found the only x-intercept is 10. That means the graph has to be below the slant and approaching both asymptotes. All right, to the right of that, let's cover up everything that's not to the right of that asymptote. The graph either has to be above the slant or below the slant. Do I have anything that tells me which? You did say it can be above? Okay, I thought you said cannot, and you're right. The y-intercept is above, so the graph has to be above and approaching that intercept. I haven't moved my paper yet to see the other y-intercept, or excuse me, the other vertical asymptote. I'm ready to do that now. To the left of the rightmost asymptote, the graph either has to be above the slant or below the slant. Do I have anything which tells me? Has to be below. So in order to hit that point and go below the slant asymptote, here's what the middle has to look like. And then to the right of x equals +3, the graph either has to be above the slant or below the slant. Can you tell me which one without having to use a test point? Has to be above because there's no x-intercept over here. And your graph has to look like it's approaching both asymptotes. All right. The reason I gave you 2 of those, Douglas, is so that we could talk about one and you would have the answer key, but you can go home and do the other one for practice and make sure, you got the answers. No, I've already taken it up. Yeah, I've already taken it up. All right, let me stop that recording because that's all I wanted to capture. I already have 3.2 taped.